indicated, my brother won a Nobel Prize in economics. And I was fortunate enough to be able to go to the ceremony and attend all of the things that are related to it. We went to two countries, Sweden and Lithuania. My brother was the first Lithuanian that won a Nobel Prize. There were others that won from Lithuania, but they weren't Lithuanian. They moved to that country. And so that's how Lithuanian became involved. Now this presentation I gave to our China outreach friends in Ann Arbor. And so this is part of that. This is part 2 of the presentation. Part 1 you can get on YouTube. And there's some cards, Alan. Let me first introduce Alan Lelevich, my son-in-law, and also Don Peterson, who came to the so thanks for the welcome there.
What's Don's relationship?
To what?
What's Don's relationship?
Cousin.
Thank you.
So he and his wife attended me. So if you have any questions, you could also ask Don, because he was there. So if you pass those cards around, you can see part 1 of this presentation at home on your computer. So we'll get started here. Once you win a Nobel Prize, your life changes, I think, forever. Here's my brother in Beijing, China, last month. The Chinese are having yearly meetings of Nobel winners, and this is the second summit of China. They're going to have this every year, so they're very interested in these awards. As I indicated, this is the second part of the presentation, and I'm not going to talk too much about Alfred Nobel. You can find a lot of information on him on the internet. But we're going to focus on who were the 2013 Nobel laureates, what were the Nobel Awards, why were they given, in brief summary, and then how are the Bible and the 2013 awards related. So I want to start out with an illustration of one of my brother's books. In the middle here, whoops, in the middle, this one here, is written in English. It's called The New Financial Order, Risk in the 21st Century. Now this book has been translated into about 28 different languages. I show the Spanish version here and the Chinese version here. Those are the covers of those books. Now when you ask a translator to translate a book, you want him to first understand it in English and then reflect the same ideas in the other translations. That's what you want. Now why do we bring this up? It's because God has given us 2 books to read. One is the book of the world. That's called General Revelation. The author is God. He both blessed the world and cursed it. And then we have God's Word, the Holy Bible. That's called Special Revelation. And it's given to us, inspired by God. But the Bible is not cursed. The world is. And so we are to read these books and get from them what we can. Now I put the Nobel, whoops, hit the wrong button. The Nobel Award here by the symbol for the universe, because the Nobel laureates, which book are they mainly reading from? The world. We're supposed to read from it, but we can learn from what they find about the world. Now, this illustrates the struggle that all humans go through. The shadow figure in the middle is supposed to represent you. Between the arms is the Chinese symbol for you. It's pronounced ni. That's you and me in the middle there. And I drew some rubber bands that are tugging us to either the idea that the world is the only thing worthwhile reading. And the other idea is that the world and the Bible are worth reading. And then we translate those readings into our own book. And I show a book here under the legs of this shadowy figure. That's our internal book, where we translate what we find in the world and what we find in the Bible. Now, we sometimes don't translate it correctly. We get some things wrong. Let me give you an example. Dr. Nieper is a woman's health expert, and he said women should not have children after 35. Does anyone know why? Why should women not have children after 35? Because what?
Because you're teenagers when you're going through menopause.
That's a possible interpretation. But you want to know his answer? His answer is, isn't 35 children enough for any woman? What happened there? We associated the 35 with the wrong word intended by the original author. Then there's one more example. Jesus Christ said, I am the door. Now, do you ask, what kind of wood are you made of? No, we don't take the first level literal translation. He is a door, but it's on a second level. So we got to make sure that when we read the Bible, that we're on the same level of the original author in terms of, because there are different levels of literality. And when we define truth, we should probably define it as truth is that which corresponds to reality as perceived by God, because we don't always perceive it accurately. Alfred Nobel, he lived from 1833 to 1896. He's the inventor of dynamite. He had about 90 weapons factories that produced weapons of war, and he was very upset with the carnage and the destruction of the human race brought about by these inventions of his. And so he set up the Nobel Awards to award people who benefited mankind. And for this last year, 2 awards were given in physics, 3 in chemistry, 3 awards in physiology and medicine, 1 award in literature, 1 Peace Prize award, and 3 awards in economics, and that's where my brother comes in. Now, if you had just 1 word to describe each one of these awards, for physics it would be creation. That's what the physicists are trying to do. How did this universe come to be? And that relates to Genesis 1 and Revelation 21:1 and other spots of the Bible. Because all things were created through Christ, for Christ. And then there was 3 awards in chemistry, and the 1 word would be entropy. The entropy is the scientific term, meaning the degradation of the human race and other things that are falling apart. It's the natural things from going from order to disorder. And that's what the chemistry award, 1 word, would describe. And then the 3 awards in physiology and medicine, the 1 word is wow. I'll show you some things that illustrate the Psalm 139:14, that we are fearfully and wonderfully made. And we'll get into that in a short time. The other awards in literature, the Peace Prize, and economics deal with human sin. So the 1 word is sin. And we'll see some of that. Now, the Nobel laureates are doing what they do best, discovering. God creates, the Nobel laureates discover. And we're going to learn a little bit of what they discovered. I'm going to start out with Alice Munro. She won the Nobel Award in Literature. And she is called the Master of Contemporary Short Story by the Nobel Committee, The Mysteries of the Human Heart. So she's revealing things that are sinful in our behavior. So she's helping to understand the human condition. And these are the words of the committee. They say her short stories rely very little on external drama. We see a lot of turmoil on the outside, but she's focusing on the turmoil inside the person. And that committee said if you read a lot of Alice Munro's work, you will come face to face with yourself. And they say it's leaving you shaken, changed, but never crushed. Apparently she does it in a gentle way. The Bible also contains points of disturbance, short stories that if you read enough of the Bible, you become face to face with yourself. And the idea is not to crush you, but to offer solutions through Jesus Christ. And there are lots of points of disturbance brought out by the Bible. One that's a lot of people have struggled with is that you can't earn your way to heaven. It's a gift from God. That's a difficult one for many people. And there are many Bible stories. The Samaritan woman at the well, prodigal son, his brother, woman caught in adultery, story of Jonah, where a preacher is asked to go to the Gentiles and preach to them. And he said, no, I hate those people. He said, I know you're a loving God, and if I go and preach, they might just get saved. So that's a point of disturbance. But I'm going to not go through those stories. I'm going to give two examples from the Nobel trip itself. One is the Diocletian disturbance, and the other is the Nobel Peace Prize disturbance. This is the Diocletian disturbance. And Emperor of Rome, this is Diocletian, that's a bust of his head. He was Emperor of Rome from 284 to 305 AD. And this is where persecution of Christians by the Roman Empire hit its peak. And there was a young Christian martyr who is known as either Saint Lucy or Saint Lucia, who died at the age of 21 during this persecution by the Roman government. And the picture is a little dark here, but if you go to the first part of this presentation on the internet, you will see some students from the University of Stockholm that came on Friday the 13th to my brother's hotel room as a send-off after the award ceremony. They sang the St. Lucia song. It's in video on the first part. So they're still celebrating some of the Christian martyrs during the Roman persecution. And a picture here is a painting of Christians thrown to the lion during this period. So these are points of disturbance in the minds of the Roman leaders. The other was the Nobel Peace Prize, and that was given to the Organization for the Prohibition of Chemical Weapons. If you remember, in August of 21 of last year, at two locations near Damascus, Syria, sarin gas was used against the people of Syria, and you see some men, women, and children here that have died from that. So the question is, what kinds of points of disturbance are bringing out this kind of behavior? Okay, let's move on to physiology and medicine. The awards were given to Randy Sheckman, James Rothman, and Thomas Sudoff from the University of Cal Berkeley, Yale, and Stanford University. And they are looking at the cells that we are made of. This is the wow factor that I indicated to you before. We each have roughly 46 to 68 trillion cells because we're different sizes. That's the spread. And if you don't believe that number, you can count them. Every cell in your body functions as a small city. It's absolutely amazing. And there are bubble-like vesicles that carry waste product and nutrients and have to deliver it within the cell to where it's needed and on time. And these men that received this award discovered how the cell knows where to deliver it. Here's a picture. This is a fiber road, and you have a transporter that's walking on the road. Right now inside of you, this is happening. And you see this bubble vesicle is like a box when you mail it in the post office. And it has to be delivered to the right address. And somehow this transporter knows which road to take and where to take it. Let me show you a video of this. So not just a picture. Now you can see the vesicle being delivered by this transporter. This is happening in your cells. And it knows where to take this vesicle. And you can see it's a motor protein that regulates the walking of this. And that, to me, is a wow factor.
Tubules provide tracks along which membrane-bound vesicles travel to and from the plasma membrane. The directional movement of these cargo vesicles is due to a family of motor proteins linking vesicles and microtubules.
That each cell is like a city. Now, one thing that we have to deal with every day is suppression of truth. And when you see something like you just saw, what's the conclusion? Well, Richard Dawkins is an atheist, and he wrote a book called The Blind Watchmaker. And on the very first page, he says, biology is the study of complicated things that give the appearance of having been designed for a purpose. So when you see that last slide, or that movie, you have to hit yourself in the head and say, looks designed, but it's not. Because Dawkins spends the rest of his book showing or describing why it's not designed. And then we have Francis Crick, who helped decode the DNA, and he says biologists must continually or constantly keep in mind what they see was not designed but evolved. And chance is the only source of true novelty. He gives no credit to God for being novel. He says chance is luck. So I have a cartoon. Let's see. Let me first go to this slide. What makes God angry? If we go to Romans 1:18, for the wrath of God is revealed from heaven against all ungodliness and unrighteousness of men who suppress the truth in unrighteousness. And I think Crick and Dawkins are an illustration of that. Romans 1:19, because what may be known of God is manifest in them, for God has shown it to them. For since the creation of the world, his invisible attributes are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse. So I have a cartoon here of a chemistry professor in front of his class, and he's giving a definition of hydrogen. And he says, now students, hydrogen is a gas which if left long enough turns into people. And that's what Francis Crick, I have here an hourglass representing time and some dice. And for him, that's how we came to be. So he is saying that exact thing. You just have to wait long enough and hydrogen will go to people. Now, Churchill had some comments on truth. He said, in wartime, the truth is so precious that she should always be attended by a bodyguard of lies. They fed Hitler lies so that Hitler could not respond appropriately, because whenever you believe a lie and are acting on it, you'll respond inappropriately. And then Churchill also said, men occasionally stumble over the truth, but most of the time they just pick themselves up and hurry off as if nothing happened. And he also said, you have enemies? Good. That means you stood for something sometime in your life. But of course, if you're going to stand for something, you want to stand for something that's correct. Now, this is some information on biological systems. In English, we start off with letters. We build it into words. We go to sentences. We make books, and we put books into the libraries. In the same way, in your cells, we start off with letters. You have 4 letters in your body. They're G, C, A, and T. And the words are called condoms. They're always 3 letters long. And that codes into 64 different words, which codes into 20 amino acids. The sentences are your genes, because you put those words together, and that's your genes. And they code into proteins. Then the book is a chromosome. That's a collection of information. And then the library is your genome. And here's a chromosome map, the library of your body. It has 23 paired books, and this particular one is a male, because the last one here is an XY, has an X book and a Y book. Females have XX. And females actually have more genetic information than a male does in this last part here. Now, we're going to be discussing physics in a little while, and I want you to keep this idea of letters, words, sentence, and book and library, because we're going to talk about quarks and leptons as letters, elements as words, molecules as sentences, systems as book, and the universe as a big library. So it is a book worth reading. Let's go back to the diagram of the shadowy figure between the 2 poles. One is God in nature, and nature only. And we struggle with this. And what most people do is they don't like either pole. They don't like the God pole because you're not the captain of your soul. And they don't like the nature-only pole because it leads to nihilism. Both of those poles are repulsive to a lot of people. So what happens is we put things in between. Number 1 is theism, that's the God pole. And 7 is the nihilism, that's the nature-only pole. And so all the world's religions are parked in between. You borrow something from theism, you borrow something from nihilism, and you put it in a comfort level. And that's why all the world's religions tend to be in between those poles. But when you go in between, you run into logical problems, because all religions have to answer the questions of who am I, where did I come from, how shall I live, where am I going? So it's origin, who am I, morals, and destiny. And if you are parked at a place that's not the truth, you will not be able to answer these questions in a very comprehensive and logical way. Okay, let's go on to economics. I'm moving fast here because we're trying to get a lot of material in a short period of time. My brother is here on this side. He won the award with Eugene Fama and Lars Peter Hansen here. My brother's at Yale, the others at University of Chicago. And they are called trend spotting in asset markets. They're trying to address important economic questions. Do market asset prices reflect the true value, or do they rather represent irrational and sentiment-driven values? And what would be the consequence to society if you misprice assets? And can asset prices be predicted? Eugene Fama said in the short term there's no way of predicting. It acts like a random walk. My brother said if you expand the time horizon, you can see trends in the data. And he also started a new field in economics called behavioral finance or behavioral economics. And that brings in the sin part of human behavior, because it's not just pure economics. And this is just a quick example. If a stock makes a dividend announcement, it generally goes up 5 or 6% for 12 days afterwards. But after 12 days, you can't tell that a dividend announcement was made. That was from Fama. My brother says if you go to a little bit longer time horizon, like 7 years, you can see some relationship between dividends and stock price. And that leads to behavioral economics that my brother is starting as a new field of economics. But in the Bible, they've done this for many years. Like St. Thomas Aquinas, in his book Summa Theological, asked, what is a just price? How should we deal with poverty? And then also in the Protestant Reformation, John Calvin, in his book Institutes of the Christian Religion, whole sections were devoted to government and economics. And then we have the book of the Proverbs, many parables of Jesus, and how to view our financial assets and how to deal with it. And when my brother was in Japan last month, in its response to a question from the Chinese, he said, that's the vision of a good society. It can't be perfect because people will never be totally unselfish and loving. We have to try to develop a system that balances different human aspects. And we're trying to give the idea that we're created in God's image, but that image is tarnished. And because of that, we have some problems. The economic implications that individuals need to be protected from sinfulness by designing an appropriate economic system. We need private property and assets must exist because of biblical principles, and freedom is needed to exchange property and in a free market. And those are some of the economics applications. And then let your yes be yes and your no be no when you enter into a contract with somebody. Things fall apart if we don't honor our contracts or our word. Okay, let's go to physics. You may have heard of the God particle last year as it was bandied about. And the awards were given to two physicists, Francois Englert of Brussels, Belgium, and Peter Higgs of the United Kingdom. And the particle that they found is called the Higgs boson. That's this year. And he proposed it in 1964. And the particle represents a 40-year search and an expenditure of $10 billion to find something that lasts 1.6 times 10 to the minus 22 seconds. So this God particle doesn't stay around for very long. Where did it get its name, the God particle? It came from this book here by Leon Lederman. The book's title is The God Particle, but its subtitle, If the Universe is the Answer, What is the Question? And this was published in 1993. It's actually a marketing technique to call it the God particle because you'll sell more books. Now, Peter Higgs, who proposed this particle, said he's not all that amused by the nickname God particle, as he is an avowed atheistic naturalist. So he has chosen that far pole. And so he's a little bit annoyed that it's called the God particle, but it does sell books. And to me, it's bewildering that non-scientists sometimes take the Higgs particle as a disproof of God. And as you talk to people, you may find that the God particle is a thinly veiled attempt to mock belief in the supernatural creator, and such a name is actually deceptive. And you'll see cartoons like this. One says, "I found God," on this t-shirt, and the other one says, "I found the God particle." And underneath it, it says theology versus physics. And some are implying that only one side has physics, but actually there are some very good Christian physicists as well. Now, you'll see the spiritual warfare going on here. This is from the CNN. You can actually see the video if you go on your computer, where a CNN announcer is talking to Michio Kaku. Are you familiar with Michio Kaku? His picture is over here. He does a lot of explanation of science, and you'll often see him on television. So the announcer is saying to him, "This isn't just science. This is how science may actually disprove religion, because you say you cringe when you hear the God particle. Is that where we may be headed to this?" And his answer is, even more than that. He says, "Realize that the Higgs boson takes us to the instant of creation itself, and we can run the videotape before the Big Bang. We can talk about the universe before the creation of the universe itself. If our universe is a soap bubble of some sort and is expanding, there could be no other soap bubbles out there, other universes."
All of it from this explosion triggered by a Higgs-like particle.
Okay, it's still very complex, but I know that you often break out into the sociological implications of science as well. This is the beginning of a very, very big conversation, isn't it? This isn't just science. This is how science may actually disprove religion, because you said you cringe when you hear God particle. Is that where we may be headed with this?
Even more than that, realize that the Higgs boson takes us to the instant of creation itself, and we can run the videotape before the Big Bang. We can talk about the universe before the creation of the universe itself. If our universe is a soap bubble of some sort and it's expanding, there could be other soap bubbles out there, other universes. And so this is where the next step beyond the Large Hadron Collider comes in. We're going to look for evidences of a pre-Big Bang universe, perhaps the existence of other universes. And then, of course, we have the question that everyone asks me, is Elvis Presley still alive in another parallel universe?
Is he?
Maybe. You can't rule it out.
Come on, we're going there? Really?
We're going into areas that take us before the instant of Genesis chapter 1, verse 1. We're talking about going before the beginning itself. I tell you, this is deep. This is really deep. It has philosophical, theological implications as we talk about a universe, a parallel universe, other universes out there coexisting with ours. And the Large Hadron Collider, this gigantic machine in Geneva, is the key to perhaps proving the existence of these other dimensions.
And Peter Atkins of Oxford University said on BBC, "The Higgs boson is another nail in the coffin of religion." So there's some spiritual warfare as they struggle between those two poles. Now, what is the Higgs boson? Well, actually, Peter Higgs and other physicists back in 1964 found that if you took mass out of the equations that they had, the equations simplified greatly and looked very beautiful. There was symmetry in them, so it was easier to run the equations, and it looked beautiful to them. So Peter Higgs says, why do we put mass? We know that things have mass. That's known. But why don't we bring something from the outside of our equations? We'll assume that there's a field in space that gives mass to particles. So we can make our equations more elegant by putting that field in. And I have a picture here of piano strings on a grand piano. It's sort of like the space is filled with many invisible strings. And then if you pluck it with enough energy, out pops a Higgs boson. But for like 10 to the minus 22 seconds, so it's very short-lived. So he's proposing this, and the reason why he's doing that is he fails to recognize the Trinitarian nature of these particles and you have to bring in something to try to describe their Trinitarian nature. And it cost $10 billion. There's a proton accelerator that is between the countries of France and Switzerland. It's 17 miles long in a big circle. It's 300 feet below the ground to get rid of interference. And then it has super cold magnets, an extremely expensive setup. And they're still spending money on it to dig deeper into these questions. Here's first look at the cartoon here. We have a professor trying to explain the Big Bang. And a student is saying, let me get this straight. First there was nothing, then it exploded. So the idea, well, you say, do people really believe that something can come from nothing? Well, there's a book here that you can buy at the bookstore, A Universe from Nothing. And Cross is the, Lawrence Cross is the author. He's an atheist, and he says, as he talks about his book, he says, there are 3 kinds of nothing. And according to the laws of quantum mechanics, each one of them left to itself will produce the something that we see around us. It sounds like the ultimate free lunch, Cross admits, but there you are, it's just science. That's so. Now he's invoked a trinity of nothingness. Now I don't know how you distinguish nothing number 1 from nothing number 2 from nothing number 3. But they have their trinity. The atheists have a trinity. So you can see how the minds work here, and how they're hope. Richard Dawkins had the foreword in this, so he comments on how great this book is, how we can come from nothing. There's something wrong with that idea. All right, let's look at the standard model of particle physics. Early on in human history, we felt that there were air, fire, water, and earth were the 4 elements. And as we learned more, we came to the periodic table that there's roughly about 100 elements. And then as we went through and discovered more, we found that each of those elements are made up of electrons, protons, and neutrons. And then as we go further into physics, we find these elementary particles, quarks and leptons and force carriers. Now, these here can be considered, unless these are made up of smaller stuff, these can be considered letters. Then those letters form words. That's the elements. And then you put the elements together, you get molecular science sentences. Then you go into books and systems, and then a library is the universe. So it's very similar type of construction. So these are kind of the letters of the universe. But not like our letters, these carry the meaning, not just the symbol. Our letters carry symbols. These are the symbol is really the meaning. Okay, here's an expanded chart of that. Like we have 6 quarks, 6 leptons, and these are the force carriers. I think they have to invoke the force carriers because you're trying to bring in the Trinitarian nature of these elementary particles. A proton is made up of 2 ups and 1 down particle, and a neutron is 1 down and, or I'm sorry, 2 downs and 1 up, and that makes the difference. These have a plus 2/3 charge. This has a minus 1/3 charge. Now, the masses of these are very carefully balanced, because if the proton was not heavier than the, if the neutron was not heavier than the proton, the universe would collapse. So the masses of these things are very important. There are 3 families. Family number 1 are the stable ones. We sit on the chairs in the building. Those are the ones that are stable. The others are more fleeting in nature. And you can see that some of these resulted in Nobel Awards. And they added a new particle called the Higgs particle that was recently observed last year in the collider. So, but it's more complicated than that. They're not finished with these. There are actually 48 types of
Will this be on the exam?
Pardon?
Will this be on the exam?
Well, if you want an exam. Here are those quarks and leptons, and then you have the gauge bosons, then you have the antimatter, because each one of those has an anti-equivalent, and then they say each one has a supersymmetric equivalent, and those they're still doing research on. But the supersymmetric, they named one after you, Frank. It's called the Schramm. And that's let's see, that's the charm. The charm particle, it's supersymmetric, so you must be charming too. Then there are three constants, because a lot of these other things vary. Speed of light, gravitational constant, and Planck's constant. And point out the Planck's mass, which is 2.18 times 10 to the minus 8 kilograms. That's a very small amount of mass. If you've seen a fruit fly, it's the mass of a fruit fly egg. And that's where that mass, if you're above it, you're in Einstein's relativity. If you're below it, you're in quantum mechanics. And that's about the mass of a fruit fly egg. And this is the standard model. We're not going to go through this equation here. This is the Lagrangian. And it's the standard model, now requires 20 parameters to be inserted with no understanding of their inner link of those parameters. This is an unfinished business. These are very good equations. They do predict a lot, but they don't predict everything. And the Lagrangian is simply kinetic energy minus potential energy, and that's what that all is. Then you have to know how to manipulate it. So let me, God says, where were you when I laid the foundations of the earth? And we're trying to figure them out. To find the Higgs boson, there are two theories. You get a curve of number of collisions in the collider versus energy. And if there's no Higgs boson, you get a smooth curve, and you get a little bump if you see the Higgs boson. And here's a watch. It's called the Higgs boson watch. You can buy, I think it's about $40. And it has the debris traces of the Higgs boson when it decays. So you could be the first in your block to have one of these. Here's an early graph of events versus mass, and you see some of the elementary particles in that those boxes that we showed you. And I put Nobel Awards. Those are, you got an award if there's a blip where you predict. And here's the Higgs boson. You see that little bump between the two curves, and this one subtracts the two curves, so you can see the bump there. But it doesn't. You can't see the particle itself because it's too short of a lifetime, but you see its debris, and that's how they. Now, physicists are trying to do a theory of everything. So they want one set of equations to explain everything. But we have two sets of equations. We have general relativity that Einstein did, and we have quantum mechanics on the small scale when you're below the mass of a fruit fly egg. Those two things are mutually incompatible. They're disjunct, and they are having trouble to unify them. And I think part of it is because the Trinitarian nature of nature. And so they're finding it's very difficult. And there are also some real mysteries. You've heard of dark matter and dark energy? Well, if you look here, this is a galaxy of rotating stars. This is number 2903, spiral galaxy. And if you measure the speed of those stars, some are coming toward us and some are going away. you plot a graph from the center of the galaxy, you see that stars' velocity tends to increase and sort of level off. And this is where there's no stars, this gray part. You can see the rotation of the gases that extend beyond the galaxy. Now, if you know physics, look, there's something drastically wrong with this behavior. It should look like this, where the speed goes further down. And so physicists propose, because they can't explain this, they say there must be dark matter halo around the galaxy. We can't see it, we don't know it's there, but to make the equations work, you've got to invoke that dark matter. And there's a graph here. This 4% is the matter that we can see. The chairs you're sitting on, the building, the universe, 4% is what we can see. Dark matter, 22%. Dark energy, which expands the space, is 74%. Now, they're trying to find these things, but how do you find something that's dark? You can't see it. There's another model here by Moshe Carmel. It's the Carmelian model. Contains the same kind of physics that this standard model does, but it requires no dark matter, no dark energy needed. You need an extra dimension, but it fits with the Bible's 6,000 year old in Genesis. Now, which one is correct? There's still time. I mean, they both have correct things in them. The question is, are they totally correct? And I don't think anyone has a totally correct model. But you at least have some explanation of how the Bible in 6,000 years could take place. I have this slide to illustrate Einstein's struggle with his worldview, because when he did the equations of relativity, he woke up one morning and said, oh my goodness, this implies a beginning to the universe. So he put in a cosmological constant to stabilize the universe. And later on they found that, no, you need a beginning. And now physicists almost universally accept the fact that the universe had a beginning. And, but it shows how our struggle between those two poles, how we sometimes let our belief system influence how we determine our equations and how our physics is done. And that leads us to this question that Christians debate. Is it creation days or is it long periods of time? And there are some Christians like Moshe Carmeli and Helton Arp who would bring out things that go against the standard beliefs, and they get punished for it. This movie, Expelled by Ben Stein, shows how Christians are punished for their views, and also Robert Gentry for his work. And we don't have enough time to go on this because we're almost done here, but I just wanted to give you an approach of how to try to decide how old the universe is. I have here a column labeled 6,000 years and 115 billion years. There was a debate on this. Dr. Terry Mortensen, a Christian, was arguing for 6,000 years, and Dr. Hugh Ross, also a Christian, was arguing for 15 billion years. And then we have the different items that they brought up and how they debated it. I'll only point to a couple things. Evolution, 6,000 years, that can't happen, right? Not enough time. Remember, Francis Crick, you have to have time and chance. In 6,000 years, we don't see changes rapidly. So that would throw evolution out the window. But there are 8 types of evolution, and one of them is true, and that's the one that the Bible supports. That particular one we see, and I'll have an example here in another slide or two. Whereas in the 15 billion years, you can say God used evolution and directed it. I could have had another column here for the atheists, just which one they will pick between these two. the 15 billion years. So Noah's flood, worldwide, if you're 15 billion, you say local flood destroys a column. You can't have that because the geologic column is used to date the fossils. And so you can't have a universal worldwide flood. This is the Bible 4,000 years from creation to Christ on one chart. And so if you're believing 15 billion years, where are you going to put it in? Either before all this happened or somehow work it in. The large number does a lot of things to the Bible that you have to work in. Here's the curve, that S curve that relates to the chemistry, which is the degradation of the human race. This is plotted out from Bible data, and you can see that after the flood, the length of people's lifetime drastically decreased. Why? What happened at the flood? We started with a lot of people, and we put them through a bottleneck. You had, I don't know how many people before the flood, but let's say it's 1 million. Then you throw them into 8 people. And 8 people had to intermarry to procreate. Adam and Eve were created perfect. And so you didn't have this problem to begin with. But as you go through a population bottleneck, it does serious damage. And that's why we have laws that you shouldn't marry too close in. Because if we did that, and many rulers trying to keep the power in the family have witnessed this degradation in the human race. Let me go on, I'm running out of time here. Let me just go, these are the 8 types of evolution. There's cosmic evolution, which people call the Big Bang, coming from nothing. Chemical evolution, the origin of chemical elements. Stellar and planetary evolution. Organic evolution, life from non-life. Microevolution, one kind of life into another. Microevolution, changes within a kind, and that's biblical. That one is supported by the Bible. And I have a picture here, 2 parents that have twins. One's black and one's white. They were in the center of the human genetic code, like Adam and Eve. And you can see other pictures like this of black and white twins. This idea of human races, we only have one race. That's the human race. And we get all tied up if we don't follow exactly what the Bible says. Because you can find many pictures like this. Then there's human evolution, belief that humans are still evolving, that will go into something like a Superman. We're going downhill. Then there's moral evolution, belief that mankind is improving morally. The one that the Bible supports is number 6 here. Stands for mankind. The idea that you have changes within a kind. And we're going to finally get to chemistry. These are the 3 award winners. There's virtual chemistry, and they have developed chemical models to make the job of the chemist in coming up with new products easier. And these models are good for all types of chemistry, but the most important one have been in the fields of biochemistry and molecular biology. And this one is very personal for me. I have here the formula for Tasigna. It's a medicine that I'm taking. It's designed, here's the shape of that molecule. It's like a puzzle piece, and it targets a specific protein. See, I was diagnosed with leukemia. It's a blood cancer. And this thing acts like a straitjacket, deactivates it, and so my blood levels are normal. If this thing didn't exist, I wouldn't be here today talking to you. So kudos to the chemists that have done this. And so I'll end with congratulations to my brother on his winning the award, and I'm thankful that I was able to attend these sessions. It was really magical, so I encourage you to look at your home computer part one of this. So with that, I'll close.
Well, John, thank you.
Sure.
It's a great opportunity. Something that we don't always get to witness or hear about. So congratulations again to your brother.
Well, thank you.
And it was great that you were able to make the trip.
Yeah, I enjoyed it.
It's a blessing in
Yeah,
itself.
it is. Yeah,
So thanks again.
sure.